I hope this presentation will be a good explanation for you why I'm here and why you are in Budapest. So it started in 2008 when I studied in Durham. I did my master course in paleopathology, and that's how it started basically, because with my supervisor Tina Jakub we had to decide what I will write about in my thesis, and we decided to do children. And I had already a material from Hungary, 1,000 grave cemetery, which was very big. So basically that was the first case when I met with this route to childhood, and I'm happy that it ended today here. So basically, as you saw from the title, we will deal with setbacks. And what are our starting points when we want to basically know if there was a setback, a crisis in the past? Of course, there is the foundation of the theory by Goodman and Armalagos, but Rebecca showed an even better or more advanced diagram today. But basically, the simple way that we are under evolution and we have to adapt to the environment. We have a cultural system which can buffer of the negative effects of the environment, but meanwhile, we also causing negative effects, of course, on the environment and on ourselves. But every segment of the population reacts to these negative effects in a different way, because every stage of the human life have different challenges. And actually, children who are under development, so they are very sensitive to these negative effects. And actually, if stress appears, then they respond very quickly. And how can we detect stress in ancient populations? Well, the first thing what we do, sex and age data, and we try to reconstruct the mortality of these populations. And actually, as we heard many times today, that in the beginning, everybody was interested in the adult population, and children were in the background somewhere, and however, they are the rate of adaptation. Their mortality is the rate of success of adaptation in populations. And of course, if there is a long-lasting negative effect, then it will appear as a stress in the physiological system and on the bone tissue as well. So we can detect with pathological lesions if there was something problem on this level. And there is the growth. Very many growth studies appeared 20 years ago, especially. Nowadays, I think it's a little bit reduced, but it's also an important tool to detect stress. And medieval period, what I chose, but it was not on purpose always, because that was what I had, but actually it was very fortunate because the Middle Ages is quite long enough to study or detect environmental cultural changes. And we have, of course, written sources and paleo-environmental sources, and these can be referred to our biological data. So now we are in Hungary, and the Middle Ages, I'm talking between the 12th and the 16th century, and the first and the second half of it. The first half of it called Arpadian Age, after the kings from this family, and this was a quite flourishing and, let's say, more balanced period. After the Christianization, many settlements starting to form, monasteries will be founded here, however, not without negative effects, of course, because of the Mongol invasion, but eventually the country recovered, and yeah, so it's a balanced period. However, in the 14th century, we start with advanced urbanization, and the agriculture starts to develop, but after the death of King Matthias, there will be inner conflicts in the country, and it will be a good ground for the Turkish occupation, sadly, and it will be a very hard physiological and psychological pressure and economical on the local populations, and of course for the incoming populations who came during this period. So the cemeteries I will talk about, the first two will be from the Arpadian Age. The one Kana was my thesis material, is a medieval cemetery, and it was the first large XQ excavation in Hungary, which was a whole year excavation, so very big field was excavated, and as you see from this little film, we not just excavated the cemetery, but the whole village around it, and since then I think that's the biggest rural village from this era still. And the next cemeteries from Fejér country is Perkáta Nyúlidülő, is basically, this cemetery has many phases and still ongoing, the research of it with the young colleagues. So it's more than 5,000 graves, and as you see, it started in the 10th century with a row-line cemetery, and after the Christianization in the 12th century, it became a Christianized community. They start to bury their people around the church, and in the 14th century, a common population will settle here and continue to use the area. Actually, there is also a Ruskian population, but it's not important now. So, so you see this cemetery in one geographical location, but the two periods are here. So, and the other late medieval, let's say late phase of this Middle Ages in Hungary from Paks, it's also a church-run cemetery, also excavated the settlement nearby, and all three cemeteries, are very fortunate because they have high number of individuals. They were complete excavation, so the cemeteries are completely excavated. All of them are rural populations, so same lifestyle, and settled populations. So we don't know about huge immigration into these populations. And I analyzed these materials which will be involved in this presentation, so with the same aging and sexing methods, and probably with the same mistakes. So, mortality first. When we talk about mortality, we talk about mortality of the population first, of course, because now many studies started to look at, in the last few years, differently, because now we can differentiate attritional, let's say, normal biological mortality from mortality when a population is crushed by a crisis like pandemic, etc. And here you see one publication from Rebecca Garland and Professor Chamberlain. And well, I will not do this now because we will focus on children, and it's a more advanced statistics. So anyway, but when we compare the ARPA-DNH, Kana, and Paks-Cseresnyés with these conventional dominical statistics diagrams, then we see that in Kana we see these two peaks when females tend to die at younger age cohorts and males in the older ones, which we explain that females were in the risk of childbirth and things like that. And but in Paks-Cseresnyés it seems that males tend to die also at young ages, and actually the females are a little bit in the older age cohort. But what is interesting that in children there is a difference. So in the ARPA-DNH, in the early childhood seems to have a peak, and in the late medieval phase, in the older childhood has a peak. And actually, I had a master's student, and I asked her to do mortality of children in this period, and she found the same, but she compared, of course, more cemeteries, Libor-Csilla, Csilla-Libor. And actually, in Perkáta, I will not explain now this, why the two adult population is similar, probably because we are actually a continuously used cemetery we are in, so we don't know what the funerary practice changed and etc. So maybe not just mortality explain why the two adult population are similar, but actually what we see in case of children between the two periods, it's the same as we have seen in the last other two cemeteries. So going now into the non-adult mortality, then we see that in Kana, so in the ARPA-DNH, the child ratio is very low, while in Paks-Cseresnyés we see what we actually almost should see, so half of the population, cemetery population, were non-adult was non-adult. And in per capita, however, not that striking the difference, but we see the same. So there is a rising of the ratio in children. And when we look at non-adult mortality, we have to look separately the infant mortality, so the children who died in the first year, because yeah, it's another measure, because every stage of the childhood has different challenges as well. So yeah, the riskiest is of course at birth, and actually I have to refer again, Rebecca and Mary Lewis did a comparison between rural and industrial medieval and late medieval infants, and actually what I cannot do this the same, because we have very low numbers of infants actually in Hungarian middle-aged cemeteries, and we don't have so many urban cemeteries. And you see the very low numbers of neonatal death in every cemetery, but if we do as a percentage the total number to individuals, of course neonatal death is rather due to endogenous factors, so the genetic disease and etc. And it seems that in the late medieval phase, maybe the pregnancies ended up not very fortunate in the late medieval time than previously. But if we compare the post-neonatal death, which usually rather due to exogenous factors, so it's responsible, the environment into the child is born, it seems that it's more or less similar, so did not really change between the two era, and according to this publication, if it becomes similar, then it means that and the birth time of birth is also, and the positive outcome of the birth is better, then it means there is a higher level of hygiene and the better conditions. So, but we don't see here in any period. And when we put the ratio of different age groups in these cemeteries, first the Arpadean age, it seems that what we usually see that in the early childhood is most of the deaths. And of course, because of the weaning and the children tends to go into the space actually and contact with everything. So yes, it's a risky time, but after it will drop the death of children. While in the late medieval period, it will not that obvious. So the ratio of older children will stay high, let's say. And if we combine these cemeteries, it's the same. So that was a kind of conventional approach of life tables, but they not really consider mobility, fertility, etc. And it makes a direct link between infant and adult mortality. So therefore, it started to be used, the so-called death rate, which understanding the interplay between early and late childhood, in the age-independent mortality, and it compares the average mortality between age class 6. So we basically divide the older children ratio with the younger age cohort, and it will give a rate. And there is the predictive statistics, which is, I think, is still on development, but it's very exciting, and it's using Bayesian statistics, so it's based on probability, of course. So I did this death rate ratio, and as you see, it's the same picture that in the late medieval cemeteries, this ratio, when it's higher, it means that more older children dies in that cemetery, and also in the combined sample, you see, like, I could put a mirror into the two columns. So yeah, it's saying the same, that in the late medieval phase, somehow older children death will not drop like in the Arpadean age. And yeah, when you visualize with the line, you see this crossing between the age 6 and 10. And it's what they call the probability. So we basically want to visualize what was the probability of dying of this death ratio. I think I tried it out, but I think it will show the same result. I think it's good to see something like this, and later on working on with that. So the two diagrams representing the two periods, and the darker plot is meaning that's the older age group, and if they are overlap, it means that the death rate ratio is closer to each other, and if you see in one period, the two cemeteries are close to each other. So in the Arpadian age, children indeed tend to die more in the early ages, while in the late medieval period they tend to die also in the older ages, and there is no big difference between cemeteries. And if we combine again the samples, we see the same. And when we combine the cemeteries from one in each period, then we see more clearly that actually even not overlap these plots, so they are very wide from each other, which means that there's a significant difference, and actually they are very narrow, which means that there is no so big variation probably in the death rate ratio. Yeah, so there is a switch. And there is the pathology, and of course when we're dealing with children, they have a specific pathological pattern. They have more metabolic disease-related pattern because they are sensitive to nutritional defects. They have very serious periosteal reactions when they have some very serious infections. So that's the two things what I looked at in my PhD. And so cribra orbitali and cribra crani, and regarding infections, I looked at endocranial lesions, so sign of infections mostly, probably, and in the endocranial surface, you see down, and subperiosteal newborn formations, like the bone deposition due to periostitis on the long bones. And I was doing, of course, individual frequency, but after I was not sure if it's enough because I really wanted to do the true prevalence of the periostitis, because not every skeleton has all the bones, and it doesn't mean that he or she didn't have periostitis, just we don't have all the bones. So it was the same methodological purpose, for instance, in cases of trauma by Becky Gilmour, and so I divided the diaphyses into 3 phases, and I made different. So I looked at also how many complete bones I have and how many of them has periostitis and how severe and what the extent of these periostitis. And actually it was interesting because the individual frequency did not give a very significant difference, but this bone element analysis did give a significant difference. And endocranial lesions, and actually in Cana, the Arpadian age cemetery, were more severe and diffuse lesions, and even, and I'm just saying that to imagine, those who are not anthropologists, so in Pax cemetery, in the late medieval cemetery, there were periostitis only on the bones of the leg, while in Cana even it appeared, for instance, in the arm bones, so very widespread infections, and even Pott's disease were in 2 children. And the third thing is the growth studies, and that was my thesis in Durham, actually. And I also compared Arpadian age and late medieval cemeteries, and one of them is actually from even the Turkish period, Fonyod-Bézsénypuszta. And it's an immigrant population from the Balkan, so incoming population, and they are called Raskians. So I also looked at, just noting this, so what's happening here, that the femoral length were plotted against dental age. So actually, I also looked at if children who had some severe pathological lesion tended to have lower values for the femoral length, but it was not significant. And but what was, yeah, and if you look at the end of the line, however, there are many colors, but if I just put one cemetery, you would see that after the 10 years of age, these dots tend to go into 2 directions, representing that the boys and the girls start to pubert, and their stature, their growth will be different, like today. Girls are higher at younger ages. So, but when we look at these growth lines, we see that in the late medieval time, these values are much lower, in Fonyod-Bézsénypuszta especially, while in the Arpadian age, at birth, children tended to have longer femurs. But it will be the opposite and the end of the line. So the growth line is crossing each other around the 10 year of old age. And how we interpreted this, that basically, however, these late medieval children, probably because we know that there was so much conflict in the country, and so deprived, and actually this population have many interpersonal conflict signs and etc. So children tended to have probably lower weight, lower values in growth, but after around the puberty, they will undergo a growth spurt. So, and this population I mentioned is the Raskins, and actually this population in the Carpathian Basin, skeletal population, is the highest regarding stature, and still today Dalmatia is, and competing with Sweden, are the highest stature now. So, yeah, Mario, I think you are a good example. So I read this, so it's not up to me. I'm just saying that maybe not every case, but sometimes gene is a very strong force on growth and can basically with pay off, probably, so causing other health issues in the adult life is stronger and will get over the early childhood negative problems. So, so the conclusion that we have differences in non-adult mortality and health and growth in between the two periods. And in Arpadian age, we have lower mortality, but for instance, high frequency of lesions, while in the late medieval age, we have high mortality with low frequency lesions. And why is that? So basically, that's the proof of the osteological paradox, which means that when a disease, simply explaining, when a disease lasts not long enough, an infection, just few days, then will not leave any signs of skeleton lesion. So, but of course, there will be high mortality. So in what period is more stress? It seems that in the late medieval time, and probably the high mortality is caused by such infections which were rapid and very lethal, so let's say a kind of epidemics. And actually this death rate ratio which I talked about was used now in more extent publications, Pine and Bolden. And they say that it's a very good rate to see if there was a crisis in a community, because lethal infections, when once hit the population, this DRR will be higher, and actually older children are more affected because they somehow are also, like in adult population, in epidemic, everybody is dying. And of course, if these are signs of crisis, so we have to go on further that. So Irene Barbieri and her colleagues are doing very complicated and complex demographic analysis, and she used also this D-index code, but they showed the same, that in the two big plague epidemic, especially in the Black Death, there was a higher rate of this index. And actually, what is interesting, that after such high mortality, there will be a high fertility. So, and actually, this plague and epidemics have major social effect on the population as well, because, for instance, in the medieval time, early marriage were more common. After the epidemic basically build another population which will be more sensitive again to the next epidemic crisis, actually. And short-term effects, well, it can happen as well, of course, and it's very hard to detect. And Canon was again who gave me an idea, because even though what I've seen, but there were some scurvy cases, and it's very strange, because we usually see, especially in this Ottoman period, so we have some nice publications, but why was here in this very well-nourished medieval village, basically seasonal negative effects can also appear, and in the Arpadian age there was also, like today, cooler and not very cold winters following drought, and basically these were sometimes causing famine. in those years, and actually the Mongol invasion. So there are negative but not long-lasting effects, fortunately not. So, but what the problems that we really have to be aware what cemeteries we want to put into such, under such a scope, because I also analyzing now the Roman cemetery, and the age of the different age cohorts of children are very biased. So basically, when in a population there is cremation or very huge migration, then or very bad preservation, so it's basically very hard to see the same nice patterns. However, it's not hopeless, because the Pine and Boden show some crisis even according to mortality in the Neolithic, Bronze Age, Iron Age. And of course, out of our bioarchaeological view, which is bioarchaeology still, I think, but paleo-environmental groups are actually analyzing this period, and they are calling it already Dantean anomaly, so this little cold ice age, and of course, probably in prehistoric, they have also groups who are analyzing these crises due to environmental major changes. So we not the only one, and how can we play with this further? Of course, with the new aging methods. And that's why I didn't want to go into detail the adult population, because I used, well, other methods, but today, the transition analysis. So maybe I have to start again with so many skeletons, but or on the new materials. But yeah, and of course, when we do now many data, sex data, because of the DNA or the peptide analysis of children, so imagine to explain this mortality with the knowing of the sex of the children, because we know from modern populations that, for instance, at the time of birth, more boys tend to die. And of course, the more advanced many methods, so I don't want to go into this. And what is with archaeology? So it's up to you when we give this data, and you have to do something with it. So I can just think like how this changed, for instance, the funerary practice when or the cemetery usage after or during such epidemics. So we have to collect so many data temporally and spatially, so space and time, to see what's going on. And of course now, you know, of course, histogenes, we have many, it's from the team publication, and my colleagues are also in it. So we have many generations, and actually it's theoretical, but these generations probably experience different kind of stress, different duration, the frequency, etc. So can we detect with the help of anthropology or the what we've done, not just with classical methods, of course, and can we detect the crisis? And of course, not just biologically we change, but culturally. So can we detect, for instance, in these generations, difference in funerary practice, etc. And actually, the DNA is a very important tool, because, of course, now we know that not just the gene with mutation changes, but the epigenetic, so the gene expression, and it's more quickly, actually, and even, as Rebecca mentioned to you, very short negative effect causes serious health problems in the adult life and in generations, and actually paleo-epigenetic is on the route, I think. So, but not I am the only one now in the country, and you will meet, for instance, my two colleagues, Kis Krisztián or Tamás Szenicei, who has very nice results with colleagues about our age family connections. So, as you see, we have many signals from the past and science, what children also had there in the past. And actually, I think when we research on them, we really find these biological things, but my very personal experience that we find very precious things. And they were not born with sins, but I think with ancient wisdom. And I want to share with you with a 10-year-old girl from the 19th century America, and I think her little poem is just as valid today as it was then. Very little things are we. How might we all should be? Never quarrel, never fight. That would be a shocking sight. Just like pretty little lambs, softly skipping by the dams. We will be gentle all the day, love to learn as well as play. Thank you very much.